So we're about to kick off with our next talk. Sam Tracey will be doing a deep dive into functional programming. So, round of applause, Sam.
I came across this problem quite recently, and I had to work it into my talk, and I'm going to try and use functional programming to solve it later on. But I'm curious as to if anyone's got any thoughts. So the first question there, a woman has 2 children and at least one of them is a boy. What is the probability that the other one is a boy? So any thoughts, ideas? Yeah?
2/3.
2/3 that the other one's a boy. Okay? Anyone else? Yeah? Half. Okay, put your hands up if you think half. Most of you. Hands up if you think 2/3. Hands up if you think something else. And you know what you think? Yeah? What do you think? 25, quarter. So we got half, a quarter, and 2/3. So this is not a trick question. You'll see later on that the answer is 1/3. Okay, all right. So we got a nodding head there. So. Right, so that's the third. What about the second one? The only difference is that I'm saying that at least one of them is a boy born on a Tuesday. Anyone think it's different from a third? One person. Do you know, or are you just saying that because I wouldn't ask if it wasn't good? Yeah. Okay, so well, it is different. And I find that a bit weird. So we'll see why that is later on. So this is journey into functional programming. Just to gauge you, could you put your hand up if you're not even a computer programmer? So if you put your hand up if you are a computer programmer but you don't know very much about functional programming. Okay, and put your hand up if you know at least a few things about functional programming. Okay, so got my work cut out to make everyone happy, so I'll just put it on the line here. I'm going to upset everyone. So who am I? So I'm Sam Tracey, and I'm not a career computer scientist. In fact, I started off as a chemist. I did a bit of research in that, and then I was a chemistry teacher for most of my life, and then I made videos for a chemistry magazine until recently, until November, and then I quit my job to teach myself computer programming, and although it's a bit more complicated than that, I've done that several times in my life, so I'm not a complete beginner. But this time around I said, I've heard about that functional programming, I'll do that. And it seems a bit weird to aim for some niche thing, but I thought I'll be focused about what I'm learning. And it's kind of worked out for me because I applied for a job recently, and because it was a job programming in this programming language called Elm, there probably wasn't much competition, and I'd met the people in the Cambridge meetup group that I was a member of, and so I got that job. So, but apart from that, my point is I don't know what I'm talking about. So those of you who do know about functional programming will say, no, he's got that wrong, and those of you that don't know about functional programming, well, you won't know and you'll think I'm really clever, but I'm just pretending. So I'm going to introduce you to some of the ideas there and hopefully give you some idea why I'm enthusiastic about it, why I like it. So why learn functional programming? I mean, it's a bit hyped up, so there's a few reasons. So people will tell you that it really increases your productivity, and I think that's true, but it's probably overstating it, and you've got to do what your employer says anyway. But it will make you a better programmer. I think that's the most important one from my perspective. That's what I've done. And it will make debugging easier. And you'll enjoy going back to projects that you made 6 months ago and changing them, adding to them, leaving them for 2 weeks and not thinking about them and coming back and continuing. That's really much better. So many projects that I've started as hobbies, I go back to and I think, I don't understand what this means. and so I just give up with it. Where functional programming, it saves that, and you can mess around with it anyway, and you won't break it. And the reason for that is, well, there's a few reasons, but to give you an idea of how it works, that's different from some languages like JavaScript and Python that you use, is it's a compiled language. So JavaScript and Python, you write the computer program, and it might tell you a few syntax errors, but mainly you won't know whether it's working or not until you run it. And then it will say, oh, you made an error here, oh, you made an error here, and then someone else will do something you weren't expecting, and it will say, oh, I'm not doing this, I'm breaking. And whereas with a compiler, it's very strict, there are very strict rules, and it'll just say, I'm not building that, I'm not letting you put that out until you get it right, until you obey all the rules and make sure that it's logically correct. And you'll get an idea of this when I show you some code that I'm going to try and make. And so once it compiles, you won't get any errors. Now that's different from saying it's right, but you won't get runtime errors, you won't get exceptions, it won't just stop working. But that doesn't mean that your, your Pac-Man won't suddenly turn into a ghost and die or something like that. You may have made some logical error. Particularly if you're doing anything with graphics, I've found it will be wrong. But you won't get any runtime errors, although sort of null is not an object or whatever it is that you get in JavaScript all the time. If you ever inspect any web page that you're looking at, whether it's by Google or Facebook or whatever, and look at it, it's just full of errors. And you're like, how did they manage to get that out? Make something in Elm, no errors. And that sort of tempted me to learn it. I didn't understand it, but that's what I wanted to do. And it makes your code easier to reason about and become more employable. Well, it worked for me, but still the number of jobs in functional programming are very low, but the ones that do exist are higher paid, and being good at functional programming won't make you worse at being a normal programmer. Oh, and it's fun. So there are cons. It's got quite a steep learning curve. Going into this, even if you're a good programmer, you'll think, I don't understand this. You'll feel like a beginner again, which I think is fun, but some people hate that. And so for certain things, dealing with big data, it's not very good. So if you've got a big list of numbers, then as we'll learn, you can't just change the numbers. You have to copy the whole list with the new numbers that you want them to be. So if your list is very long, then that's going to take a lot of time. But I'm talking like millions of numbers long, which like web applications and things normally isn't the case. And even then, some of the clever compilers means that you won't notice a difference anyway. Oh, and I said in the last one that your colleagues will understand your code a lot more because it's easier to reason about, but if they don't know functional programming, they'll be like, what are you doing? What is this witchcraft? So, some examples. All of the languages now allow you to use functional programming techniques. And if anything else, I hope you go away and try some of the ideas out. Go read about them and try some of them out in your code to see if you can make them do things. So JavaScript, C++, all those ones there. And some of them have libraries. For example, JavaScript has a library called Ramda that you can use that helps you to do functional programming. But then there are ones that are pure functional languages or functional first. The most famous one is probably Haskell. You saw my little cartoon earlier on. This, the one that I'm doing is Elm. The other ones are mentioned there. Now, the advantage of these is that they give you a syntax that makes it easier to do functional programming if that's what you want to do. And as well, it will stop you from cheating if you choose something like Haskell and Elm. You can't then use the other style of programming. And that forces you to learn it, and it also guarantees that idea of not getting any runtime errors. So what is it? I'm just putting lots of long words on the screen. So oh no, that's the next slide. But it's a programming paradigm. That means it's a different idea, a different way of doing things. So the way that you're probably used to, if you're using Python or C#, they're imperative languages. This is a set of instructions. You say, right, take C, and then double it, and then add the words foobar on the end, and now spit out that answer. So it's a set of instructions. Whereas functional programming is declarative. You say, this number is 7, C is 7, and now I'm going to create a new number which is 2 times C, and now I'm going to create a word which is equal to that 2 times C with foobar added on. So you get the same result, but you haven't gone through a list of things. You've defined a set of values and relationships between those values. And it's kind of like mathematics, which some people are like, well, I hated mathematics, but some people like, because at least mathematics, when you did it at school, when you got the answer wrong, you could accept that. Unlike English, where I would get terrible grades and I'd never understand why. So here's lots of long words that you'll hear associated with it, and I'm going to explain what a few of those mean. So it's full of long words. Don't worry about it. I'm not going to use them. I'm going to show you what the ideas are. So in the imperative languages, you'll see this kind of thing a lot. X equals 3, x equals x plus 1, which should upset us if we learn in maths at school. Hold on, is x equals 3 or is x equals 4? Make your mind up. And that's clearly equals here is being used in a strange way. Whereas in functional programming, you're not allowed to change the value of something. If x equals 3, x will equal 3 tomorrow, and in 10 years, in 100 years, it will not change. That's what immutable means. Now this is important because the way we do things a lot is to use for loops. So we loop through numbers, and this involves taking let x equal 1, do some stuff, now increment x to 2, do some more stuff, etc. But you're breaking the rule there. So there are no for next loops in functional programming. Likewise, you can't do this. I could have a function that I pass values to, x and y, and you pass x and y, and you do some things with x and y, and you pass something back. That's okay in functional programming, but what's not allowed is to take the x and y and then do something to z over here, or to change the screen, or download something from the internet. That's not allowed. The only thing that functional programming things can do is do things to the numbers that you gave it and then give you something else back. So, as I said, they will always return the same thing each time. So let's say I define a function y. Is that big enough to read? So if y is a function of x, f of x, and z is another function, and it's a function of two things, y and another y, then it must be true that z is g of f of x and f of x. So I'm just taking y, which I said is f of x, and put it into z. That must be true in functional programming. It's not necessarily true in imperative programming, because you could have done something else. Someone else could have done something else. This is why we upset each other as programmers a lot, because we're messing up someone else's function. In functional programming, that's impossible. That's why you don't get these errors, why they're guaranteed that you can't get these errors. So an important idea that's related to this is function composition. So I can create one function from other functions. So let's say A doubles a number, and let's say B adds 3 to it, and let's say C then takes the logarithm of that. Then I can define a new function, H, that takes all three of those and combines them into one thing. And the way I would do that is I take the first function and take what comes out and put it into the next one. And what comes out of that, I put into the next one. So we end up with this kind of syntax with piping, which is saying apply the function A to our number x, what comes out, put into C, and what comes out, put into D. And that's very powerful. And then you can also, in like Elm and Erlang, you can write it like this, and it makes it very readable. If you call your functions instead of A, B, and C, you call it double it or add to, then it almost reads like a bit of English. Now I'm going to skip through some things. So the other thing that's important is that the types of variables must stay the same. So if something's an integer, it must always be an integer. If it's a string, that means a word, it must always be a word. And we normally, with our functions, we say what types it will take. So, for example, the length function. It takes in a string and it returns an integer. So length of enumerable, so length is the name of my function, enumerable is the argument that I give to my function, and 11 is what's returned. So enumerable is a word, that's a string, and it spits out an integer. Notice that I don't have any brackets, like in your normal programming languages, you probably have join bracket a comma this. So this is where the syntax becomes very simple. We just have the name of our function and the list of things that we're given to that function. So here, the function join takes a string and a list of strings, and it produces a new string and spits that out. So the first one, look at, you can probably work out what it's doing. It's adding an A in between each of those letters. We can also pass, instead of just passing in values, well, I've already said that a function is a value. Like double 6 is always 12. So double 6 is a value in its own right. So I can pass in functions to other functions. So this filter function will look at a word, in this case R2D2, and it looks to see if each of those letters is a digit. So I'm passing in this function isDigit, and that isDigit function is demonstrated there. IsDigit is a function that takes a character and returns a Boolean object, which means true or false. Then it takes a string, which in this case is R2D2, and it spits out the string. And this is just to say that we want really complicated types, but we put them there because it helps us to reason about what we're doing. So if we can't do 4 next loops, then how does it work? How can we possibly... So there's 3 different bits that you're seeing here. You're seeing the Elm program. Now Elm, you write and then you compile it, so it gets built and it gets compiled or built into a JavaScript program that then gets embedded into some HTML, which is the normal thing that a browser reads. And this is then viewed over here. So in reality, if you're programming, you would just write this. This is showing what it gets built into, and then showing what output that would give. Now we're not interested in this bit today, so I'm going to hide that. So that's a simple example of a program. That's all it was running. It's taking a function called range and giving it 2 values, 1 and 10, and it produces a list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me change that to 5, just so that I don't. I have to recompile it, and if I've made an error, it should do it properly. So I've got a list from the numbers 1 to 5. Now I want to double that. Now I'm not allowed to change my list, and I'm not allowed to use for next loops. So I have to use this idea called recursion. So here's my function called double, and it takes a list of integers, which means whole number, and it's going to return a list of integers. So I'm going to look at, there's two cases that are possible. Someone could be mean, for example, and pass in an empty list. Now notice this list is written in square brackets, so this means an empty list is passed here. If that's the case, return an empty list. Or, and I've got something here called pattern matching, which is good, which is saying x, this is read as cons, and then x's. Now what this means, this cons is an infix function. What infix function means, it just goes in between two things, kind of like number plus, like the symbol plus. Plus goes in between 1 and 2. So it does something to 1 and 2 when I say 1 plus 2. So that this thing does something to x and x's. Now x is a number and x's is a list of numbers, and what it will do is add that number onto the front of the list. So if I do 1, cons, 2, 3, 4, 5, I will get the list 1, 2, 3, 4, 5. What I'm doing here is the opposite of that. I'm looking to see if that's the case. So I've passed this list into here, and it gets down to here, and it's saying, is the thing you've given me a number and a list of things? And the answer is yes, it's the number 1 and the number and the list 2, 3, 4, 5. So I've basically defined these two variables. So the number, in this case I'm going to call x, and I'm going to double it. And then I'm going to add it to what's left, but I'm going to double what's left. But by double I mean I'm going to pass it back into that list. So I've got 2 times x. Let me just show you that this works. Right, so using that function double works, but let's try and think through why that is. So the first time it comes through, I'm saying what I've got here is 2 and the list, or 1 and the list 2, 3, 4, 5. So 2 times x is actually 2 added on to double 2, 3, 4, 5. But double 2, 3, 4, 5, I can think through, I can reason through, and that comes into here. And it's not empty, but it is a number followed by a list. It's the number 2 followed by 3, 4, 5. But I've deleted it now, but it will be 2 followed by that list, but that 2 will be multiplied by 2, so it will be 4. And if you reason through, you'll see that what I eventually get is a list being created, which is 2 put onto a 4, put onto a 6, put onto an 8, put onto a 10, and then when I come down through the next time, it'll be an empty list because I've used up all those numbers. So it will add on an empty list. So it will be 2 added on to 4, added on to 6, added on to 8 to create that list. Okay, so that's the most important thing in functional programming. Now there are many, many more things that I was going to say, but I understand that I've gone quite heavily into that, but I've hopefully given you a taster that it's good for working with lists. Now perhaps the one thing I should do is show you the answer to that probability question.
Just say real quick, we're about 3 minutes.
3 minutes?
Yeah.
Right. So here I'm defining a type of child, and I'm saying a child will be a boy or a girl. So if I've got 2 children, then I have a boy or a girl, and I want to make a new list which is every combination of boy and girl with another boy and girl. And we have these magic ways of doing this in functional programming, and this is called creating a Cartesian product, apparently. But all I'm doing is taking boy, girl, and another boy, girl, and combining them, and that's the output that I get there. So I can have boy, 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 girl, boy, or girl, girl. Then I can use things, this is something I didn't get to talk about, called filter, where I'm going to take my 2 children and filter out any where the first one has a sex of boy or the second one has a sex of boy. So this is saying 2 children, one of whom is a boy. And then I'm going to do one other thing, I'm going to say 2 boys. So I take my 2 children and I filter out only the ones where the first one's a boy and the second one's a boy. So I'll just connect that. So if I've got 2 children and one is a boy, I'm basically saying I don't have 2 girls. So there are 3 ways that's possible. And I said, what's the probability that I have 2 boys? Well, there's only one way of doing that, boy, boy. So there's 1 out of 3 ways that that's possible. So I won't go through the code, but it's in the presentation, which I'll give you the link to. If I've got 1 child, there's 14 ways if I'm interested in what day it is. So boy on Monday, boy on Tuesday, etc. Girl on Monday, girl on Tuesday, etc. I then use that Cartesian product idea thing again, where I can combine this time sexes and days, and 2 children. To get 2 children, 2 children, there's 196 ways of doing that. That's 14 times 14. And then I can filter out that list, only the ones that have a boy born on a Monday, etc. And what you'll find is, if I have 2 children with 1 boy born on Tuesday, there's 27 ways of doing that. And 2 boys, 1 born on a Tuesday, only 13. Sorry, that should say 2 boys. No, 2 boys, 1 born on a Tuesday. This is 2 children, 1 boy born on a Tuesday. It's 13 out of 27. So there's an example of how it might be used. So I have mentioned hardly anything there, but if you want to see some more examples, including examples of where you might go to learn more about that, then they're on here, and there's a link to this PowerPoint presentation here. Okay, sorry I didn't get to talk about all the many things I like about it. Any questions? Any comments from people that do functional programming? Yeah.
One or two quick questions.
So, what do you think was the hardest bit for you to wrap your head around functional programming? In particular bit, or was it just the whole structure?
That recursion and trying to solve problems like that really is hard. And also within those, sorting out those algorithms is this idea of edge cases. So you saw that I had to check that it wasn't empty and knowing what things to check for. But the compiler helps. So I don't know, if I randomly do something, it will tell me quite specifically where I need to be, and it will tell me in this case that something's missing. And this is perhaps the really good thing about Elm, is knowing, is searching for. So if I took away that edge case that checks for it. So it says I haven't considered all the possible branches. You need to account for the case where there's an empty list. So this is why compilers can help you find where you've forgotten to think about odd situations. Yeah?
Which ideas from the functional paradigm would you take to the iterative style of programming?
Yeah, good question. So the idea of, if you can avoid it, your functions should not mess with values that weren't passed to it. So they should only ever change, they shouldn't really change anything, but if they're going to change something, only change the values that have been passed to it. So they shouldn't be changing some value that they're not touching, because particularly if you're working as a team, you could be writing a function that breaks someone else's code, and they got no warning of that. They got no idea that has happened. There were three functions I wanted to talk through: map, reduce, filter. I used them, but that didn't really help. They're the three that I would start with, learning what they do, and they're really useful. They'll be quicker than writing out 4 next loops when you're changing lists, etc.
Thank you very much.
Okay.